The chapter is polynomials for standard 9 and this is part 5. We have been doing problems related to the factor theorem and remainder theorem. So, yet another problem. Find the value of a if the remainder is same when polynomial fx is divided by x plus 2 and x plus 1. So, you have a here. So, we have to find this value a. It is given this is divided by x plus 2 and x plus 1 and you get the same remainder. So, that means f of x is divided by x plus 2, you get the remainder as f of minus 2 is the remainder. Similarly, f of x is divided by x plus 1, then f of minus 1 is the remainder. It is given the remainders are same. So, that means f of minus 2 is equal to f of minus 1. So, we will find now f of minus 2, substitute the value of x as 2 minus 2 here. So, you get minus 2 the whole cube plus 8 into minus 2 the whole squared plus 17 into minus 2 plus a into minus 2. So, you get minus 8, 32 minus 34 minus 2a. So, you get this as 10 minus 2a. Now, we will find f of minus 1, again substituting x is equal to minus 1 plus 8 into minus 1 the whole squared plus 17 into minus 1 plus a into minus 1. So, we get this as 1 plus 8 minus 17 minus a minus 16. So, minus 8 minus a, 8 1, oh yeah, okay, this is minus 1 the whole cube is minus 1. So, 7, so 7 minus 17 is minus 10 minus a. Now, we can equate f of minus 2 and f of minus 1. So, we can write 10 minus 2a is equal to minus 10 minus a, because f of minus 2 is equal to f of minus 1. So, from this we can say bring a this side. So, minus 2a plus a is equal to minus 10 minus 10. So, we get minus a is equal to minus 20, 10 minus 2a plus a. So, we get minus a. So, minus 10 okay, this is minus 10, sorry, minus 10 minus 2a minus 10 minus a it is, yeah. So, you get minus 10 minus 2a is equal to minus 10 minus a. So, minus 2a plus a minus 10 plus 10. So, this will become 0. So, you get a is equal to 0. Using remainder theorem, factorize this polynomial. So, this is a slightly different type of problem. So, we using not remainder theorem, it is factor theorem. Yes, theorem, it is using remainder theorem using factor theorem, factorize 6x cube minus 25x squared plus 32x minus 12. So, here we have to find the factors of 12. So, the factors of 12 are plus or minus 1, plus or minus 2, 3, 4, 6 and 12. Now we have to see whether 1 minus 1 plus 2 minus 2 etc. are factors, are zeros of this polynomial. If they are zeros, then you get it as substitute, you get the value as 0. So now let us do if you do plus 1 and minus 1, you will not get it as 0. So I am trying it with f of 2. So you get 6 into 2 cube minus 25 into 2 squared plus 32 into 2 minus 12. So if you substitute this, you get, simplify this, you get 48 minus 100 plus 64 minus 12. So this, if you do, you get it is equal to 0. So that means f of 2 you got it as 0. That means x minus 2 is a factor. Now you have to again, so you can do either the long, now you got one factor, now you can do the long division method and then find the quotient and again factorize that, or there is another method we call that as the synthetic division. Instead of doing the long division method, we can use this method also. So first we will write down the coefficients of these x terms. So 6 minus 25, 32 and minus 12. Then x minus 2 is a factor. So 2 is a 0 of the polynomial. So we will put 0 here. So now we will write down this as 6 only. So 2 into 6 will become 12 here. Then you will add this. If you add this, you get minus 13. Then minus 13 into 2, it will be minus 26. So again you add, so you get 6. 6 into 2 is 12. So if you add, you get 0. You have to get the value of here as 0 because we know x minus 2 is a factor. So first we have to if you do this long division also, you will get the same values only. So here this is an easy way of finding it. So we just write the coefficients first and then the 0 you will put it down here. The first number you will write it as it is and then multiply 2 into 6, 12, then add this minus 13, then again multiply 2 into minus 13, minus 26, again add, you get 6, 6 into 2, 12, you get 0. Now you will write this as the quotient is 6x, now it is x cube, so this will be x squared, 6x squared minus 13x plus 6. Now this is the, so this will be this is a factor. Now we can factorize it using splitting of middle terms. So we can write this as 6 into 6, 36. So 12 into 3. So 4 into 3 into 3. So 9 into 4. 9 and 4 you can use. So we can write this as 6x squared minus 9x minus 4x plus 6. So this will be 3x into 2x minus 3 minus 2 into 2x minus 3. So we get 3x minus 2 into 2x minus 3. So now we got the remaining two factors also. So the factors are factors of f of x are x minus 2 into 3x minus 2 into 2x minus 3. So here what must be added to this polynomial to obtain a polynomial which is exactly divisible by x minus 3. So, this means this is not divisible by x minus 3, you will get a remainder. So, you have to add some number. If you add some number, then that polynomial will be exactly divisible by x minus 3. So, for example, if you are dividing 25 by 4, so you get 6 into 4, 24, you get 1. So, you can, if you subtract 1 from this, it will become 24. So, that will be exactly divisible. So, for subtraction it is minus 1. For adding, so here in numbers you can easily say now 25, then you can add 23. So, you get 28, 7 4s are 28. So, you can add 3, but in a polynomial you cannot say exact number. So, instead you can say add minus 1. So, it is equal to subtracting minus 1. So, you will say add minus 1, whatever the remainder you get, the additive inverse of that you add it. So, that will be exactly divisible by x minus 3. So, we will do the factor theorem. So, we will see what is the remainder now. So, by remainder theorem, so f of x is divided by x minus 3. So, the remainder is f of 3 is the remainder. Find out the remainder and then add the additive inverse. So, here it is divided by x minus 3. So, this is a linear polynomial, that is it of degree 1. So, your remainder will be a constant. Always the remainder, the degree of the remainder will be less than the degree of the divisor. So, the divisor degree is 1. So, the remainder is going to be a constant. So, you can use the remainder theorem. So, f of 3 is the remainder. So, find f of 3, that is equal to 3 cube minus 3 into 3 squared plus 4 into 3 minus 15. So, you get this as 27 minus 27 plus 12 minus 15. So, that is equal to, this get cancelled, it is minus 3. So, you have to, so you get the remainder as minus 3. So, you will add plus 3 to the polynomial. So, add additive inverse of the remainder. So, it is add plus 3 to f of x, that is it. So, that will be exactly divisible by x minus 3. So, we have a similar problem, but it here what must be subtracted from f of x, so that the result is exactly divisible by gx, this. See here the previous problem, it was a linear polynomial, that is polynomial with degree 1, but here the divisor, the degree is 2x squared. So, your remainder can be of degree 1. So, we have to write the remainder as ax plus b. So, now factorizing. So, now here 2x squared plus x minus 1, we will factorize this. So, you get 2x squared plus x minus 1, 2 into 1, 2. So, you can write this as 2 into 1. So, 2x squared plus 2x minus x minus 1. So, that will be 2x into x plus 1 minus of x plus 1. So, you get 2x minus 1 into, so here x plus 1 you are taking out. So, you are left with 1 here, that is the 1 here. So, x minus x plus 1. So, the factors of the divisors are this. Now, it is exactly divisible by gx. So, now we have to find, if you find gx f of, so the factor, the zeros will be, okay, so f of x is divided by 2x minus 1. So, f of half will be equal to 0 by factor theorem. Similarly, f of x is also divided by x plus, because both these are factors of f of x. So, f of x is divided by x plus 1, you get f of minus 1 is equal to 0. So, now we will find f of half is equal to 4 into 1 by 2 the 4 minus 2 into 1 by 2 cube minus 6 into half plus 2x plus 6, this is equal to 0. So, we get 4 into 2 into 2 into 1 by 2. Sorry, here, yeah, see, I am sorry, gx, so now when you are dividing with this number, it is not exactly divisible. Now we have to subtract something from this number that will make the f of x exactly divisible. So, here f of half is not equal to 0. We will find f of half and f of minus 1. So, you will get a remainder. So, we will write down 4 into half to the power of 4. Yeah. So, you are getting a remainder of ax plus b. So, this is equal to a. So, here ax plus b and here also ax plus b. So, you get a into again half plus b. So, here you will get 1 by 4 minus 1 by 4 minus 3 by 2 plus 1 plus 6 is equal to a by 2 plus b. So, solving this, this will get cancelled, 6 plus 1 7, 7 minus 3 by 2, 7 minus 3 by 2 will become 14 minus 11 by 2 is equal to, taking the LCM here, it will become a plus 2b by 2. So, from this I will get a plus 2b is equal to 11. Hope you are clear now. Here it is not exactly divisible as of now. You are getting a remainder of ax plus b. So, we have to put f of half is equal to ax plus b, f of minus 1 also is equal to ax plus b. So, now we will do f of minus 1. So, f of minus 1 will become, substituting 4 into minus 1 to the power of 4 minus 2 into minus 1 the cube minus 6 into minus 1 the whole squared plus 2 into minus 1 plus 6 is equal to again ax plus b. So, a into minus 1 plus b. So, you get this as 4 plus 2, then this will become minus 6 minus 2 plus 6 is equal to minus a plus b. So, 2 can get cancelled, 6 can get cancelled. So, 4 is a minus a plus b is equal to 4. This is equation 2. Now, solving these two equations, a and b, you will get a plus 2b is equal to 11 and minus a plus b equal to 4. You can add this. So, you get 3b is equal to 15. So, you get b is equal to 15 by 3 is 5. Substitute any of the equations. From this you will get a is equal to 1. So, the remainder is, the remainder will be ax plus b. So, a is 1. So, x plus b is 5. So, the remainder is x plus 5. Now you have to subtract this remainder from fx. So, that polynomial will be exactly divisible by g of x. So, you have to subtract the remainder. Here no additive inverse, only in what must be added only you have to do the additive inverse. For subtraction you are simply subtracting. So, as I said, 25 divided by 4 you get 6 and 1 as a remainder. So, you simply subtract 1 from 25 you get 24, which is divisible. Similarly, here also you have to subtract x plus 5 from f of x. The result will be exactly divisible by g of x.